Welcome back to our channel, that is AI Next Generation. So in this particular video, we will use a diabetes prediction. We will use one sort of problem that is related to the deep learning, that is a diabetes prediction. We will use deep learning concept, that is we will build ANN model. Okay, first we will build ANN model, then after we will use deep learning library, that is PyTorch. Okay, so from this we will able to predict whether the person have a diabetes or not on the basis of some previous feature. Okay, so this is the objective of our this video, to predict the diabetes, whether the person is suffering from the diabetes or not, with the some sorts of, you have some features. Okay, you have sorts of some features, on the basis of that features you are just saying whether the person has a diabetes or not. Okay, so let's get start to this particular series. So before starting this video, so what particular data set what I will just use this particular in this video, you can, I will just give you the link, you can just directly download from there. And the second thing about the coding file, I will just share in my GitHub, so you can just directly download the coding file from there only. Okay, so yeah, this is the basic concept of the what we are going to use today. Okay, so yeah, let's get started. First we will modify this one. This is diabetes prediction. Okay, so we are going to use this diabetes prediction using uh, what we are going diabetes prediction using ANN, that is the deep learning model we will use, and with the help of PyTorch as a deep learning library we will use. Okay, so yeah, the first concept what we have to do, we have to import the basic library what we are going to use. Okay, so first of all what we will use, you can just write text also, no problem. Import libraries. Okay, so all the basic library we can just import here. Okay, what you will just write, the first we will always import the import numpy as np, and the second thing is that import pandas as pd. Okay, so about the numpys and pandas, if you really you are not aware of the numpys and pandas in much detail, so I will just give you the link in this video, so you can just directly read from there. Already this numpys and panda I have just written in my website. Okay, so you can just directly go there and you can just read. Okay, so this numpy only deal with the all the numerical data, and pandas where you want to load the data set. Okay, so this thing, and then after we are going to use now today is the torch vision, sorry, pytorch library. Okay, so for that how we have to import, just write import, you can just write import torch. Okay, and then after that import neural network, we want to import from the torch library, to import nn dash as nn. Okay, it means that you are just importing the neural network from this particular torch. Okay, so then after that we have to also import from basically we have to just scale the data set, all the feature we have to be scale in the one dimension we have to scale. Okay, so if we are how we are just going to scale, that thing I will just teach you in whenever we will just use the scaling concept in this video. Okay, so from where you want to take that particular library, so you can just directly take from the sklearn library. Okay, from sklearn dot processing import standard scalar. Okay, so basically what does it mean, it's basically is formula is x minus mean by standard deviation. Okay, so on the basis of that they are just scaling, and even you can just import the data loader here. Okay, so import, you can just write your from, you can just write from torch dot utils dot data import data loader. Okay, so what does it mean, I will say you in detail about the data loader. So data loader means directly you are just preparing for this particular data. Okay, for the training and for the particular testing form. Okay, so you have features and you have to target, you have to separate, you have to make some data so that you can fit to the directly to the model. Okay, for that you will use data loader, and you will create your own class that will consist of the some abstract method. Okay, that is double underscore get item length of that. Okay, so we will see more detail, don't worry about this. Okay, so the first thing is over. We have imported the libraries. Again, if we are using some optimizer, again we will use for optimizer also, so we will import from there. Okay, even you can just write, no problem. So we can that what I'm saying, import optimizer basically means we will use here stochastic gradient descent, SGD. Okay, import torch dot optim. Okay, as optim. Okay, okay, so this library we are going to use, and then after that we have to read this data. Okay, so how we will go through. So then after what, you will load the data set, load the data set. Then what you will write, just write the f equal to pd dot read csv, that is the csv file. I will show you now. So already I have in the drive, so this particular data set I will just give you the link so that you can just directly download from there. Okay, yeah, you can just directly download. Then after I want to see df dot head. Okay, for the first 5 row you want to see. So this is your data set. Okay, this is your data set. You have number of times and then plasma glucose. On the basic of this feature, you are saying whether the person has a diabetes or not. That what you are going to today particular problem is whether the person is suffering from the diabetes or not on the basic of these features. Okay, so these are the feature and this is our target. So for this we are building a deep neural and deep means ANN we are just using for building this particular model. Okay, then after that what you will see, you will see whether the this particular data set has a null values or not. First of all, just write information of this. Okay, how this data set is whether it had float value or integer value, you can just directly check. Okay, even from here also you can check whether your that data set has a null values, total number of date, total number of rows you can just count. So you have total 768 entries. Okay, so that is really less for this particular deep learning, because whenever you are just going for the deep learning, you will have at least you should have data set above 20,000 or 30,000. But here the my main aim is to just think how you are just loading the data set, how you are creating the data set, and how you are just training the data set. Okay, this is our main focus of this video. Okay, so yeah, you this is how you are getting the information. I don't think so you have any null values, but even you can just check with the help of df dot is null dot sum. Okay, you can do this one. So you're already seeing I don't have any null values, so yeah, no need to do anything. So then after that what you will just write here, even you can just check for the description of the data set. Okay, this is the description of the count, mean and standard deviation. This is the top two most important things. So you are just getting this all the information from this. Okay, so if you want to see, if you want to more analyze this data set, then you can just go for that. So this what we have already seen. Again then after that what we want to say, now you want to separate the data set, that is the x and y. But before that, if you see, you don't have to do anything. Plasma glucose and this all thing are the numerical. So only this particular class you have in the string format, that is a positive and negative. So for this you have to convert into either 0 and 1. You can use any option. You can use for loop, you can use label encoder, you can that is from the SQL library, you can use mapping system that is present in the pandas. So you can use as many as thing. Okay, so it's depend upon you what you are going to use. Okay, so for that what you will write, for first of all you will separate the data set. Okay, what you will just for the x you can just write. So what you will write here, so x, what does it will write here, x will contains all the features. So you have feature, you can just directly write, you can do basically what you can just do, you can do indexing. Okay, so what you will do, you want to select df dot ilock. Okay, so ilock is different thing. Okay, so ilock is basically, I think if you are aware of the pandas, then you definitely know that you are going for the label based indexing. And there are two type of indexing in the pandas. One is label based indexing, and another is the index based. Okay, so you're already doing with the index based. That is, you have to just pass in the numerical. That is, from particular, the first you will accept how many rows you want. I want selecting all the rows, and then after that you have to say how many columns you want. For that you want zero. I mean, this you will count from the indexing of this particular column will start from the zero. So one, two, three, four, five, six. Up to six you want means you can just write up to six. So six will not count. Okay, so you are just considering x. Then after that, for the particular last one, this is class. Either you can just write age. That's it. Df I want only age column. That is we basically for the target. So x is our feature and y is our target. Okay. So now you are done with this. So you can just even you can just cross check if you want to check. So you can just check. So this particular will not consist of class. Okay. So I think it's clear. Then after we will move to the y dot head also. You can just think it will content of this particular positive and particular the negative what you want to go for. Okay, why I'm moving for the age, I'm really sorry for that. We have target, sorry, target is our class, not age. Okay, yeah, class. I was just thinking about this is the last column, so yeah, that comes in my mind. So yeah, now you can just this is how I have just cross checked. That's why I'm not getting the error. After some times, whenever I was just feeding to the model, I may get some low accuracy. Wow. Okay, so you can just cross check once upon what you have defined, but what you have to do, you already have the numerical column. For this, you will do the scaling from the sklearn from pre-processing import standard scaler. Okay, then also you have one more thing, that is the target. So target will have positive, either positive negative positive negative. Okay, so you have to change positive as a 1 and negative as a 0. For that, what you will just write here, you can just directly write, either you can just do the mapping, or you can just do the particular for loop. Okay, okay, you can do anything, any method you can just apply for that. So what you can just do, we can just write for particular y. From that particular y you want to map. Okay, you want to map particular, you can just pass the dictionary. If it is not working the mapping system, we can go for the for loop. If that also not work, we can go for the level encoder. You have many options to go for the. Okay, so what you can just do, you can just write here for positive, you can just write one, where it gone, so that I can directly copy, it will not give me a mistake. For positive you can just write control C. You can write for positive you want to say it should be 1, and for negative it should be, it is there only 0. Okay, that what you want to go for negative, you want to say it should be 0. That's it. Okay, let's see if he will work or not. I can mention 10. Okay, so it's working. Even you can just try for the, this is the concept of the pandas mapping. Even you can use the for loop, you can just iterate if the you can iterate from that particular columns. Okay, so you have many method, you can just try with anything. So we have done the measure thing. Okay, we have imported the we have done what we have done, we have imported this library, we have loaded the data set, we have just converted the target that is in the string format to a binary constant, that is a 0 1, so that always a lab you can just think computer only understand 0 or 1, that is binary. That's it. Then after that, now what you have just done, you can just convert into the array. Okay, so yeah, why we are just converting into array, because whenever you will do the standard scalar, that will be in the numpy array, so you can just directly convert it to this particular y, what you can just convert into array, numpy array. So the mat whenever you will just multiply, means the deep learning is only the matrix multiplication what you are doing. You have all the input in the input layer, you have number of neurons that will multiply with the hidden layer, then further it will multiply with the output layer. Okay, so we will see that one. So here what you will pass here, and numpy dot array. So here you will pass that what you already have y, then after that what to data type, what it's already you can just mention in the float. That's it. Okay, I know it's integer, but yeah, you can just mention. Okay, it's depend upon you. So you can just think about the data type. It already you are just changing from integer to particular float 64. So whenever it is multiply, so you will not get anything error. That's what I'm saying. So you have just converted into array. So yeah, your half task is over about the data pre-processing step. Okay, now the next step you will go for the data normalization. Okay, what does it mean, normalization? So normalization means basically you want to normalize the values. You want to keep every value in the same place. Okay, like some it has 183 and this particular has only one. So you don't want to make too much distance between the any data value. Okay, so that whenever you will fit to the model, so every data will be in the same scale, that is from -1 to 1 or 0 to 1. Okay, that's why you are using the standard scale. So you first of all, what you will make the object of standard scalar. You already have been imported standard scalar. Okay, I have imported or not? Yeah, I have imported. Why it was not displaying, I don't know. So for that, for what you want to go for, only for the particular x you want to standardize the data set, because y is, or you can't do that one because that is our categorical columns. Okay, that is our either 0 and 1. You can't do scaling of that. Okay? So all the numerical column you can just do what you can just write here, sc dot fit. Fit will calculate, first of all it will calculate the mean and variance of this particular column, and then after transform you will write it will transform to whole data. Okay, whole columns you can just say. That's it, you will get the result. So again, you don't have any problem in this, and scaling is the one of the most important factor. Okay, whenever you will do scaling, so you are just keeping everything in data into same place. Okay, so yeah, this completed everything. Then what we have to do, then after that we will move to the particular converting this particular numpy into a torch. Okay, so this how we are dealing with the, whenever you are just converting to numpy, you can just directly apply any machine learning algorithm, that is SVM, logistic regression, KNN, anything you can apply. But whenever you are dealing with the deep learning and you are using PyTorch library, then you have to convert numpy to a torch. Okay, because PyTorch will take data type as a, they want as a tensor. Okay, because NumPy deal with the array, and in that PyTorch you have the tensor. They have the same meaning, means tensor works in the GPU format. Okay, like they will just convert every array to a GPU. That what they are just doing. Okay, so for that what you will just write here. For that you can just write x equal to torch dot tensor. Okay, and here you just write x. Then after for y, what you can just write torch dot tensor. Then again you will write y. Okay, so I don't think so you have any doubt in this. Let's see, hope so it runs. Again, you want to see the shape, you can just check for x comma y and y dot shape. Okay, so you are getting, you have total 768 entries and you have 6 column, and same goes for the target. Okay, yeah, so this was the this type of, I don't think so you have any doubt in this. But one thing you can again say, you want to keep this particular shape as a same. Okay, the target shape and the what is the input shape and what is the target shape. Okay, you can just do this one also. So how you will do, you want to match this particular, this is in the 2D, that what I'm speaking. You have 768 rows and 6 column. Here you have 768 rows only. You can even you can add one extra column, that is by self, that is one you can just add. So for how you can just add in the PyTorch, basically you can just write here from viewer, you can just write here unskews. Okay, unskews. So unskews will directly add one dimension, that's it. Okay, you can just pass here, it will, what it will do, it will add one more dimension in this particular y. You can just see. um, so what I was speaking, you were thinking this, what it is saying, it added extra dimension in this. Okay, x and y. So you are just mapping the same dimension of the x and same dimension of the y. Okay, you can even feed directly to this particular model, it will not give you the error. But You are just matching, that's what. It's not compulsory, but yeah, you can just do this one. Okay, so then after that, what you will just write here, now you will create a data set. That is, the data set is basically what you want to do here. You will just write here creating custom data. Okay, okay, custom data set, you can just say. Custom data set means you can't use that. You have to see, you have to define what are particular feature and what are the target. Okay, you have to define there. So for that, like is the loading, for loading the data set, you have to define a class. And that particular class is that will be abstract class, because it will inherit the properties from the parent class that already they are the abstract class. They will contain some abstracts method. Don't confuse about the abstracts. What are abstracts? So yeah, so abstract basically means you that particular method has been implemented in the parent class, but whenever you are just inheriting the properties from child class, so what you have to write the particular what function, what method has been defined in the parent class. Okay, so yeah, so what you can just write here, you can create a class that will, you can just name anything. I can make data set, and here it will inherit from what, it will inherit from the same, it's no, it is different one, don't be confused. Data set is already we have just imported here. Okay, this is what we have imported particular data set. So for that, what you will just write here, from sklearn. So for particular data set, what you have to just write here, you can just import from this particular data set. Okay, where it go on, you can write here data set. Then after that, you will just define the particular, yeah, so you will define the particular init method. So init method will init method, that is the constructor. First of all, you will just define here. And also you can even import we have imported data loader now. Even you can import data. Oh, we have not import data set. You can import this one. Okay, yeah, so you can just do this one also. I think it has been imported, so that it, you can inherit the properties from here. So what you will do here, you will create a data set, one class, and then after here you will just define two method. That will be the length method, and one will be the whenever get item. Okay, so for that, what you will just write here, you have already inherited, and then after that step dot init, this is the constructor what you will just define. Then here you will pass the two parameter, that is an x and y. That is x and y we already defined. Okay, you can just name, you can give the name of anything, a b, or you can give anything. Self dot x equal to x, then after what you will have self dot y equal to y. Okay, so you have just defined, you have just initialized these two particular features and target. Then after you will just define one method that is already defined in the parent class, this get item. Okay, get item I have to write here. Okay, double underscore init double underscore get item. That's why this, they are the special function, you can just say. They are the abstract function, that all the abstract method that are already defined in this particular data set. Okay, from where we are just inheriting the properties. So it will take one parameter, that is the self first, and then after that it will take the index. Index means it will go one rows at a time. Then after that it will extract that particular rows and that particular target. Okay, so what you have to just give the return, it will just give the return of self dot from x. No, from x it will go for the first index, suppose it go for the first row. Okay, and then after it will select the first column also. So it means first target also. Okay, I don't think so you have any doubt in this. You are just doing the indexing part, so that for the particular first row you will have the this target, for the second row you have this target, for the third row you have this target, what you are just matching. Okay, then again also you have one more this particular length method, you that return the length of this particular data. That's it. Okay, you can just write here, it will say the length of particular self comma x. That's what you're going to say, self dot x. Okay, just run this particular, I don't think so you have any error. Then after you can just make the object of data set, and you have to pass which one, the two parameter. You can pass, you already have the x and y, you already have defined. You can directly pass this one. Hope so will it will not give an error. And then after you can just see this length, how it works. Okay, so this how it works. Okay, so total 768 you have. Okay, so yeah, then after that what you will do, you have loaded the data set, you have the feature, you have the target, you have done everything, but now you have to divide this whole your data set into batches. Okay, or you have to shuffle the data set also. Why we are dividing in the batches? So that you can just directly you can't give directly miss button to your model or even to your laptop, okay, or your PC. So what you will just divide into batches, so that if you have 100 total, suppose you have 100 total data value, that is a row, and you are just taking batch size as a 10, so 10 at a time it will go forward propagation, and it will do backward propagation, and then it will update. Okay, this how it will goes. Okay, so for that, what there is a data loader already we have imported there. Okay, so for first of all you will have train loader. So what you will just write here, train loader, and then after that torch dot utils dot data loader. Already we have defined, but again I'm just defining, I don't know why. Okay, so no need to define again, already we have defined now. Let me see. Yeah, data loader already we have means we have imported, no need to import again and again. Data loader, and it will take three parameter. The first parameter, it will take the data set. Okay, the data set, already we have the name of the same name data set. Then after that it will take particular the batch size, how much batch size you want to keep. So we will keep 32, and we will also say shuffle equal to true. Okay, I don't think so you have doubt here in this also. Okay, so already it has been done. So yeah, so what you will want to say, just run this one. Okay, so then after, if you want to see the shape, then you can just write na, like the x comma y in train loader. You can just see the first, it will have 32 batches. Okay, it will first 32 total rows it will go, and it will go forward propagation, it will do backward propagation, it will update the bit, next 32 it will go so on so on. Okay, 32, so 32 at a time it will go, it will not go directly whole 768 at a time to the model. Okay, so you can just see when print x dot shape and comma y dot shape. Okay, you just write only for the particular first batch you are just seeing. See, you have 32 total batch, and every batch has 6 total columns. Here you have 32 batch, and every batch has the one particular column. Okay, what you are just doing here. So yeah, I don't think so you have doubt. Even you don't want to see the shape, you want to see the values, you can just look for that also. It's saying it's out of index because I'm doing self or at x. Okay. I have not mentioned self here. Sorry for that. Okay, so you are able to see this one. It will have total 32 rows. Means this is the first row, all values. That is the first row, all value. Then second row, third row, fourth row, and this is the target. First row, third row. Okay, how you can just do this one. Okay, yeah. So I don't think so you have doubt in this also. You are able to see your data set has divided into 32 batches. Then after that, what we'll do, we will build a model. Okay, so building a model is really important things. Okay, so we will see how we are just doing this one. So how you will build the model? First of all, how you will just create the model? We will just create a model that will have how many fully connected layer or how many hidden layer we want to define. We will see in this particular video. Means particular, we will first build the model. So you can just write here. Why it is not displaying at a time? You can just write here, building a broad model or creating a model. Okay, ANN model. Okay, so what you can just write here, creating an ANN model, what you will just write here. So for that, first of all, you can just write here class the class name you can just rewrite ANN or anything. Okay, so first you will write real class that will inherit from the module. Okay, module, because module will consist of all these type, you don't have to define again what activation function or what linear you have to define. Okay, already you can just directly initialize from this particular nn dot module. Okay, then after that you will just define a constructor, then after that you can just write self. Okay, so here it will consist of you can just pass the two parameter. Okay, the one parameter will be the input features. Okay, so what are input feature, I will show you, don't worry. Feature, and the other you can just part output features. Okay, feature. Okay, so you have input features and output features. So what are input feature and output feature means, whenever you are just creating the fully connected layer, so in this particular input layer, so input layer how many neurons will be there, that depends upon the how many feature input features you have. That already I have uploaded the video that is related to the how many neurons you have to take in this particular input layer or hidden layer or output layer. That is the video already I have uploaded, you can just watch through in the deep learning playlist. So about the all the layers and how many neurons you want to keep there. Okay, so the first thing what you have just see input layer, input feature means how many features you have or how many columns you have. Okay, and output feature is your target. Okay, means, so what you can just first of all create an object of that particular parent class. So super is what it is doing, it is creating the virtual object of the parent class, so that you are just initializing the parent class in it method. Okay, constructor of the parent class. So yeah. Okay, so then after that what you will just you will start the building the model. The first you will just write here self dot fully connected layer 1 nn dot linear. In the ann what you are just writing in the PyTorch, nn dot linear means you are just creating the first fully connected layer. It will take two parameter, one parameter will be the input feature and another parameter will be the output feature. Okay, so for this input feature will be it's what you are just taking this one. Okay, input feature. Okay, because it's depend upon how many columns you have in this your data set. And then after the second one is the you want to use hidden layer or not. Okay, so don't be confused. If you are really confusing in the input layer or what are the output layer or what are hidden layer, you can just directly go to my YouTube channel. You can just watch what are input layer and how many neurons you want to. I will already explain this thing in the much details. I will keep the links in the description of this video. Okay, so what you can just write here, so the first you have just created the input feature, then after that how many hidden layer you want to keep. Okay, so by here I'm just writing because it is really small model, you have only 768 total rows. Okay, so for 760 rows I don't think so you have enough total number of rows for the deep learning model to create. So you have to build small model, because it will be the whenever you are building a large model and it may give you the underfitting problem. Okay, because you have the big model and you are just fitting the data set is really small, so that will be the really conflict. And even so that about the underfitting overfitting you will see in the next video, coming video. Okay, so here what you will just write here, again you are just creating the self dot fully connected layer 2, and then after here you can just write nn dot linear. So the same thing, and then after the what will be the output of that, it is this for this fully connected it will be the input. Okay, so again you are just creating the four, this is the your second, in the second hidden layer you are creating two, you have created two hidden layer. That the first hidden layer is the 5, then second hidden layer is the 4, and 4 means second hidden layer you have 4 neurons in the second layer. Okay, second hidden layer. So then after that what you are just building fully contained layer 3 and nn dot linear, again you will have 4 3, I'm just building the same, you can just build. Okay, and then after that again you are just getting one more fully connected layer, and you are just what you are doing nn dot linear, you can write anything. And then after that what you have to write here, you can just write 3 comma and output feature, you can just write it out. Output feature basically means what, so output feature is basically how many use depend upon your class, how many class you have. Okay, so here you will take only one, because you will take only, you have in output layer you will take only one neurons. Okay, if you are taking two neurons, so it's depend upon you how many neurons you are taking in the output layer for the binary classification. If you are using only one neurons in the binary classification, that is one neurons you are taking in the output layer, then you have to go for the sigmoid activation function. Okay, the sigmoid means above 0.5 will be the threshold value. Above 0.5 you will say that is a you have diabetes, and if the calculation comes below 0.5, then you are saying that is a that person does not suffering from the diabetes. And if you are creating the two neurons in the output layer, then you have to give them the first neuron is the one consists of the diabetes, and the second neurons consist of the does not have the diabetes, and the above the two neurons which has the highest value, it will come that particular neurons will be fire. Okay, so you can go for anyone, you can create one neurons also in the output layer for the binary classification only I'm speaking. But if you have three or four neurons, okay, if you have three and four class, then you have to define as per your class, means how many class you have or how many target you have, that number of neurons you have to define in the output layer. Okay, so here you can just what you can just I'm going for the one layer. Okay, one particular neurons in the output, that's why I will use the sigmoid activation function. Okay, so you can just write self dot sigmoid, you can just initialize here. Okay, so how you will write here, nn dot sigmoid. Okay, so I don't think so you have doubt in here also, even you can just initialize for the relu. Okay, so relu, then after what you will write here, nn dot relu, this will particular we are using in the where we are using relu activation function basically in the hidden layer. Okay, so if that particular neurons or these neurons come in the negative form, so we are just deactivating that particular neuron because it will not consider the important feature, means more the values in these neurons, more the important feature is coming. Okay, then after you will define the one method, that is a forward method. You will define forward method. So here you will pass here self comma x. Okay, so x is basically your rows one by one it will just pass. Okay, the first what you will just write here, first fully connected layer 1, sorry, self dot fully connected neuron. Here you have been slide, you have just make that fully connected neurons will have this much neurons, fully connected two neurons will have this much neurons. Okay, now you are just going the flowing of this particular how the data will flow. Okay, so first it will go to the first fully connected layer. Okay, so then what you will just write here, self dot fully connected layer 1, then after you will pass this particular data x, then after what you will just apply the activation function. What will be the output, you can just apply activation function. Already you have just initialized with the relu, you can just pass the out. Okay, so it will just override, that's why I'm writing out, don't be confused in this. And then again you will write same concept, fc2, again it will pass, it will take the out. Okay, the previous input, then after again it will apply on the top of that, you are just applying railway activation function. Okay, then again you are just doing the same thing, again you are going for the out, self dot fc3, here also you would take the out, and then after that you will applying same the railway activation function on the top of that. Again this is the last that layer, fully connected layer you are just building. So here you are just taking fc3, and here you will pass particular out, same thing. And there here after this what you will just supply, I think I have written c3 c4, you can just write here. But here after that what activation function you are going, you will use sigmoid activation function. This is your output layer. Okay, so in output layer you have only one neurons, you have only one neurons in the output layer. Okay, so in the output layer you have only one neurons, what you will just write here, in that particular neurons if that particular value comes above 0.5, okay, if the threshold value comes above 0.5, you are saying that that particular has the diabetes, and if it is coming 0. Below the 0.5, then you are saying that particular person does not have the diabetes. Okay, so what you will just write here, you will again write the out, then after that you will just write self dot sigmoid what you have just created above, and you will pass out. Okay, and you will just return this output. This is your the what you have built the ANN model. Okay, I don't think so you have doubt in this. So this was the really easy, you can just see. Okay, so then after that what you will just write here, you will create the object of this particular AN. Okay, so how you will create the object of ANN, so you can just write anything, I can just write net dot, already we have ANN here, it will take two parameters, one is the input feature and one is the another is the output feature. So input feature is depends upon how many features you have in the x. So in the x total, what is the shape of the x and what is the feature in that particular x. Okay, so for that you can just pass for the input feature, and for the output feature what is that, so you can even count or you can just take the shape of that 1 2 3 4 5 6, you have total 6, so you can just pass 6. And in the target you have only 1 neuron, already I explained you about that, okay, in output layer. Then after that, what loss you want to take, okay, try, you can even loss, what you will just write loss function, you can just write here, and what you will write torch dot nn. Then after, from that you want binary cross entropy loss, okay, this is your binary cross entropy loss. Only whenever you are dealing with the binary classification, okay, then at that time you will use binary cross entropy, otherwise you will use categorical cross entropy, okay. So this already you have just done. Then after that you will use optimizer, okay, which particular optimizer you want to use. Already we have just imported, I think optim we have done. From the optim you can use SGD, so stochastic gradient descent you will use. It will take two parameter, okay, so one parameter it will take model dot all the parameters, okay, so it will take model dot parameter, and the third and the second parameter it will take learning rate, okay. So then after it will take learning rate, you have to define, you can just write 0.0001, okay. Let's see, model is not defined, why, okay, oh no, but I have done the mistake, which model is not defined, yeah, I have not run this one, yeah, it is running, model is not defined, sorry, okay, in the super I have mentioned the, okay, sorry, you have to mention the ANN, okay, sorry for that. Out feature is not defined. I know that it's basically because of the spelling mistake I have done. 110% output feature is not output feature, okay? That's what I was saying, okay. Here also I have, why I'm coming in my mind model, they are the silly mistake, you can just deal with this also. So I have done only the silly mistake, okay. So wow, at a time, it's all silly mistake I have done, yeah, now it's fine. The first mistake I have done, I will explain you, you can also do, that is the common mistake, that was not a blunder mistake. The first mistake I have done, this output, that is the ANN, this particular model I have not passed in the ANN, okay, I have passed model, I don't know from where I have just know, because every time I'm just creating the ANN model, I'm just writing the model, that's it, okay. You can just name anything, okay, what you are just writing here, you have to just call, you have to give the parameter in the super, so that it will just create the object of the parent class, okay. And the second I have done the mistake, that is the spelling mistake, that is the out feature I have just defined in place of output features, okay. And the third mistake what I have done is basically, that is the again this I have just I have not written PARAMETERS, so PAR I'm just written TRS. They are the silly mistake, okay, I'm explaining this, and you can even do the mistakes, that's are not really blunder mistakes. So hope so, we have just built the model, now it's time to training our model, okay. So now you will train the model. How you will train the model? Training ANN model, okay. I don't think so you will have doubt in this also, this will be really easy, okay. So you will able to see. So first of all, we will see only for the loss and how the accuracy is coming for that every iteration we will see, okay. So what you will just write here, first of all you will give the how many epochs you want to take. I'm taking 100 epochs. Then for epoch in, I have not defined for, I had to define only for the train loader, you can just go for the test loader also, okay, because you have already we have too much less data, that's why I'm just seeing only the training accuracy and training loss, okay. So you can even go for the testing accuracy, so okay. So what you will just write here, for epoch in range of this particular epochs, then after that you will iterate through the input of this particular input, what will be the inputs and what are the labels, okay, in train loader, okay. Train loader we already consist of the features and target, that in the batches form, you can just convert into the floats, so it will not give you the error, this data set in the float form. How you will just write here, input dot float, okay, just call this one. Similar you can go for the output also, sorry, labels, labels, you can just write here labels dot float. Okay, I don't think so you have doubt in this. Then after that, what you will just write here, then after you will pass the inputs to your model. So how you will pass here, from output you can, it will give some outputs. Okay, that what model will predict what you have just make the, I think with the net you have make the this particular net. Inside that you can just pass, you can even call dot forward. Okay, you can call dot forward, you can call this one. Okay, but it's no need to call. By default, whenever you will pass the inside net, you will pass the output, by default this method will execute. Okay, this forwards method. So what you will just write here, just write particular, you will pass the inputs. Okay, so that model, what model will predict I don't know, but you will see this one. Okay, then after that, what you will just match with the help of loss function. You have already have the loss function, that is a binary cross entropy you have taken. It will take two, that is the what is the outputs. Okay, what with out, that is the output that is predicted by the model and what was actual. Okay, this is how it will just see. Okay, this how you will get the loss. Then after you will just write, then after that you will just write optimizer. Okay, optimizer. So optimizer, you what you will just write here, optimizer dot zero grad. Okay, so zero grad is basically means you want to update, you want to keep every gradient to be before calculating the particular gradient, you want to set every gradient before to as a zero, or you are just saying the buffer what you want to set. Okay, you are just clearing that gradient, that's it what you are doing here. Then after you will just, with the help of loss dot backward, you will calculate the gradient. Okay, what if, how you will calculate the gradient, what it does it means you will calculate this one, that is the w new equal to w old minus learning rate into gradient. What you are doing this one, so with loss dot backward you will calculate the gradient. Okay, so that you will able to update the weight during the backward propagation. Okay, so I don't think so you have doubt in this also. Then after that, optimizer dot step, what after it will, now it will update whole model. Okay, so now it will update the what weights of all the particle during the backward propagation. Okay, this how you will see. So yeah, I don't think so you have doubt in this. Then after, what you will think, you can write the epochs. Now you will see the accuracy also. Okay, so how you will see the accuracy for every particular outputs. Okay, so what you are getting the output, so output is basically all the 64, you are just getting this output. You want to see the accuracy, what will be the accuracy, so you can just write. Okay, if this particular your output is greater than 0.5, first of all you will say na. So if your outputs particular what outputs come equal, this output probability is greater than 0.5, and it is, and you have to convert this thing into float. Okay, because your target is also in the float value. Okay, what you are just doing here. So now you will match with the particular labels. Okay, you are just seeing the probability of, if you are just setting that if your particular probability is 0.5. Okay, if that they are saying that this particular has a diabetes or not, has a greater probability, then what you are just setting this one. Okay, then after that, what you will just write, you will see the accuracy of this model. How you will just, if your output, okay, what your output has been came, it will match with the labels. Okay, then if it is matching with the labels, then this will give you that particular result. Okay, so how you will just write here, you can just write this thing in the inside the loop. Why I'm writing outside the loop? Okay, if this particular matching with this thing, then you are just changing, you want to float and you want to mean of that. Okay, mean means average, it will give you. Okay, accuracy of that. So this how you are just doing. Okay, then after you will just print. Okay, even what you can just do, no, you can just do one thing, that I can just say it, you can just do, you can just write here train loss, but you can just write here, for every epoch we will have different train loss and train accuracy. Okay, so what you can just write here, train loss equal to 0.0, you can, you are setting train accuracy, you are setting 0.0. Okay, that's what you are just doing, and every time what you are getting the loss, you are increasing, that's it. Train loss plus equal to, what you will just write, loss. Okay, loss, from that particular loss you will write loss dot item, you can just write. Okay, So even this what I'm saying, for every epoch you want to see, okay, so that's why I'm just mentioning this one. For the every epoch you want to see the train accuracy and train loss. Okay, so what you are just doing here, so what you can just do, you already have just seen it here. So from this particular loss you have, what the loss you will get here. So what you can just write here, you can just write loss dot item. You want only the particular item, the value of inside this particular loss. You don't want anything in the list. This how it will add up. Okay, every time what it will iteration, this will iterate, it will iterate. How many times you have batches, 32, 32, 32. Every time you will have the loss, that will calculate sum of for that particular one epoch. Okay, the first epoch you will see. So how you will just see. And for the accuracy also you can just do the same. Okay, for accuracy also what you are just writing here, if this particular output is equal to labels, then you are just saying. Even what I can just do, what you can just do, you have to just remove. I'm just checking. Okay, even you can just try. Okay, I'm just doing some tuning part. So here what you will see, if that particular what labels it has become. Okay, the what in the outputs. Okay, so if this particular output is greater than 0.5. Okay, so what you are doing, you can just leave it for now. Okay, so here you, I don't think so you have to make change in here. Okay, so what you have to do here, you already increasing the accuracy. So what you will just write here, the train accuracy plus equal to what you are getting. Okay, you are not checking for the only iteration. You, if this code you are just going for the iteration, you don't have to make any change. But you want to see the accuracy for the every box, then you have to make the change. Okay, train accuracy I have defined, what I have defined there, train accuracy. Okay, plus equal to loss the labels from that particular, you want that particular mean. Okay, so I don't think so you have doubt. Or what I can just do, you can do some, then after you can just do, I want only the item. Let's see, hope so it will works, then it's fine. So yeah, so then after that what you will just write, and now you will print this particular for the every box. This is for iteration. Now you will check for the every box. You have to write here. Then after that what you will write here, epoch. This is the first epoch you want going, you are seeing. And then after you will write training loss, training accuracy first. Right, training accuracy, you can just write this one, point to where floating value you need, and training loss. Then after that, even you have to make the placeholder inside that only I want point to a floating value. Okay, then after dot you will just write format, and you have to pass the three parameter. Okay, that is the first you will pass the epoch plus 1 because it start from the 0. And what you are getting the train accuracy, you have to divide with this particular length of what, semi, you have to define with the length of total length. We have 768 now, you can just write length of x, that's it. Okay, then after that you have also particular train loss. Okay, train loss. Then after here you will just define, because whenever you are calculating the bandwidth loss entropy, already it will give you the output for all the 32. Then here you will just define the length of train loader, that's it. 32 32 one at a time you want to see it. Let's see, hope so it works. Don't have to mention that much big, you can just write this one also. Yeah, so hope so it works. Not implemented error. Why it is giving, it is giving in the outputs. Okay, let's see what will in the, what is the result inputs, for inputs comma labels. Okay, for input comma labels in this particular train loader. So what is the output? So I don't think so you have any done mistake here, but why it is showing rise not input error. Let's see if it is working or not. So it is has been given in the output net, and whether you have, whenever you are just creating the object of this, you are just passing the input features, and then after that you are just passing the ReLU sigmoid activation function. Yeah, that's work fine. So why it is not giving the error? So again we have to check where I have done the mistake. That this is the output layer. From there you are just passing no fixed variable. View problem. What's the view problem? View problem. But it's only saying in the inputs error. But we already make the object of that. We have created the 6 comma 1. We have just passed this one. So what can be the error? Inputs not implemented. It's only showing this particular in the this particular outputs only, means you have done something mistake creating this model. That's what they are just showing. Okay, so input features, then you are passing 5 4 4 3 3, then after output feature and sigmoid layer, relu, beginner layer, relu, fully connected layer, relu, fully connected layer, relu, fully connected layer 4, then after you're just passing for the sigmoid. Yeah, I don't think so, you're mistaken this. Why it's giving error? uh, uh Input error, why it is giving me? Why I've written this one? It's only the 6. I think we have the 6 features. Okay, so let's see what is the error. It's not a big error, but yeah, I can even pause this video. I can just go for that. But I want to see, you can also see what I have done the mistake. Okay, so what you can just write here, you know what you can just write here, you can just do one thing. From net, if you are not passing the float value, then what will be the result? Let's see. That is what I'm speaking. If we are not changing this thing into float, because already we have changed into the float value. Hey, this is the same mistake. Where I've done the mistake? Oops. Why I'm doing this type of mistake? So basically, I think I have done something where I have the spelling mistake. That's what I have done. So let me check from the beginning. Even you can just watch this one. What I have done the mistake, so that I can directly use. I can just directly write and go. Even I can just write. I will just write dot forward. Sometimes it may make mistake. Okay? So I don't know, but it's like the constant. Whenever by default PyTorch you will implement only the forward method. Okay, dot forward method. That's it. If it work fine, then let's see. Wow, that was the only error, man. That's it. Oops. Okay, so for general, what I'm speaking for you, just write whenever you are doing something mistake, because see, the thing is that here the net you are just using and you are just passing the input, that's it. But by default PyTorch will implement forward method. Okay, you can't define any other, you can't write forwards, you can't write forwards underscore. By default forward method will implement. Okay, but if you want your own method to implement, then here you have to write net dot forward. Okay, that's what you have to write here. Then after you can just run. Okay, what method you are just implemented. Okay, this way also it will run, it will not give you the error. This way also you can just go. So but you can just write here for that particular forward. By default it will go and utilize this particular value. Okay, so yeah, so this was error. Okay, no dots. He's saying you don't have to give the dots. How many time it has been run, training accuracy 0.62, loss 0.68, what we are just getting. Okay, so for the every box we know that we already given the output. So this was the result of this particular, and I don't think so you have any doubt in this. So yeah, that was the really easy. So in this particular next video we will see for the particular heart attack already we have done, for the brain tumor also we have done, and for every many already we will see the different type of algorithm. Even I will explain you different type of algorithm, and again we will take some Kaggle question and we will do. Okay, so hope so this video gives you the correct way and what I have done the mistake, so you should not do that particular mistake. I know that I have done some mistake. Even I can pause the video, but yeah, you can just see what the mistake and how we have to tackle of this particular mistake. That is the common mistake that do everyone, those who are in the starting phase. Means the starting phase, like you, whenever you will start the learning, then that particular mistake you will do. Okay, so yeah, that's it for this video. Hope so we will, in the next video I will take another data set, so we will just write there and we will see. Okay, that's all. Thank you.